Our presentation deals with two valuable but underexploited written records for historical ecology of forest in southeastern France. It aims at demonstrating how such documents can be used for analyzing past forest cover composition and age. For now, forest ecologists evaluate the ancientness of forest based on the analysis of ancient maps, especially the carte d'état-major dated from the mid-19th century and the Napoleonian cadastre. Because they are often qualitative, incomplete, and at local scale, written records are rarely considered by ecologists. However, the former county of Provence benefits of an exceptional documentation with two forest surveys conducted by Navy officers based on tree counting, contrary to other modern forest surveys based on the measurement of forest cover areas. These documents were previously used by historians to demonstrate the human-driven deforestation process during the modern era and leading to the 19th century forest cover minimum. Recently, Georges PICHARD started analyzing these sources from a real ecological perspective. The first document is the General Table of Woodlands and Forests of Provence, which is a synthesis of a survey conducted by Albert de Montmort, intendant of the Royal Galleys in Marseille in the 1680s. With the help of Navy carpenters, he visited all Provençal woodlands and counted every tree. The aim was to evaluate the potential of Provençal forests for supporting shipbuilding activity of the arsenal of Toulon and Marseille. The survey concerned more than 700 communities distributed in all the former county of Provence, from the Mediterranean Sea to the Southern Alps. In this whole area, more than 12 million trees were recorded. The information available concerns the location of woodlands, then the tree species, that is oak, pines, elm, fir, beech, spruce, and larch. The trees are sorted into three categories: the trees of expectation, the trees of service, and the trees of no value, as we will see later on. The height and circumference of useful trees were measured. Finally, the distance from woodland to transportation facilities is documented. Despite the exceptional quality of the data, one should keep in mind the limits. Several tree species considered as useless for shipbuilding were not recorded, such as evergreen oak, cork oak, chestnut trees, and other secondary species which are invisible. Another limit is the misidentification of the various pine species, especially in the mountain areas. Let's move to the second document, the General Visitation of Provence Woodlands. It is a final synthetic register of a global forest survey conducted by Chabert de Lisle, commissioner of the Royal Navy in Toulon in the 1720s. This survey followed the same objective than the previous one. The survey concerned again the same area extended to the Ubaye Valley at northeast. All in all, it is more than 2 million trees recorded, distributed in more than 600 surveyed communities. We will come back later on the meaning of this low number of trees. The surveyors followed the same procedure. The main difference consists of counting, in addition to the previous tree species, oak coppices, ash, evergreen oaks, and once cork oak. At the opposite, spruce is no longer counted. The various pine species were also better identified than before. But the major difference is that when only useless trees are present in one territory, the surveyors did not count them at all. So a significant part of woodland cover is invisible in this register. First step of our work was to identify the former communities and places thanks to ancient maps and cadastres. Then all the information has been added in a database and then used in GIS for spatial analysis. Our first objective was to reconstruct former forest landscape. Let's start with the first survey. This slide shows the global forest cover reconstruction. You can see the most wooded areas were located north of Apt and in Toulon hinterland. Oaks represented nearly 50% of total forest cover recorded. It dominates east of the Durance River, especially north of Apt and Manosque area. A second concentration was located in central Lower Provence in the surrounding of Brignoles. All the species of pines represent 44% of total woodland cover. Because of the misidentification of the various types, we mapped here the distribution of Pinus without distinction. It clearly dominates in the Mediterranean area. Let's move to mountain and subalpine woodlands with the distribution of beech characterized by an important concentration in Sisteron area and west of Castellane. Fir is less represented, but three major concentrations were located at Lambris, Thorenc, and Lamartre. Spruce, which is a rare species in Southern Alps, is recorded in 3 places. Larch is more present and mainly located in Seine areas. Outside woodlands, elms are recorded as a substitute for oak, especially in western Provence. Despite the accuracy of the data, some woodlands of low extent are invisible. This is the case of the beech woodland of Montagne Sainte-Baume, while it is attested by soil charcoal analysis and written records. This is also the case for chestnut and cork oaks woodlands in the More mountains. The same spatial analysis has been performed based on the second survey data. You have here some maps of beech, elm, pine, and fir distribution. One novelty is the consideration of oak coppices in addition to high-stand trees. But as coppice is recorded as a surface and not as single trees, it is impossible to map them together. Absent from the first survey, evergreen oak and ash were also recorded. As the 2 surveys were conducted in a lap time of 40 years, it is tempting to compare the data in order to evaluate change in forest cover. But the different quality of the 2 datasets make it very difficult. How the 10 million trees difference between the 2 surveys can be explained. First of all, such a huge difference is due to a source bias. As we said, in several territories, especially in mountain areas, the surveyors did not count trees in absence of useful trees. So let's take the example of the 12 communities of Seine area in Southern Alps. While no trees are counted, the comments prove the presence of forest cover made of oak, fir, pines, and larch. Potentially, it is more than 300,000 trees that have not been taken into account during the second survey. Same issue for the community of Simian-la-Rotonde, where more than 600,000 trees are missing in 1720s. With these 2 examples only, it is more than 1 million trees missing because of source bias. However, real change in forest cover also did occur. Part of them caused by human activity such as large wood cutting for shipbuilding, clearings for agriculture, and the increase of fuel wood and timber harvest for the cities. Other changes are caused by natural drivers such as extreme cold winter and forest fire. Let's continue with former forest composition through the example of the first survey. We analyzed the global composition of former woodlands. In the open landscape of western Provence, elm clearly dominates while pine dominates woodlands along the Mediterranean shore. Central Provence is characterized by nearly pure oak woodlands, while woodland composition is more diversified in mountain areas. Let's zoom at community scale in the district of Seine. This slide shows the detail of woodland composition with mixed oak beech woodland in supra-Mediterranean and collinean zones, while in mountain and subalpine zones located east, woodland were dominated by pines, larch, fir, and locally spruce at fire fir. High-resolution spatial analysis is also possible, but it needs a long identification work of all the places. You can see here the example of individual woodlands at Prats. Please note the difference in forest composition according to biogeographical zones. Pines, probably Scott pines, dominated the montane zone, while the upper woodlands were mostly composed of fir, spruce, and larch. Finally, we tried to transform the Navy classification of trees, that is, trees of expectation, service, and no value, into age composition to reflect upon the former forest maturity. To what correspond these categories? Trees of expectation correspond to young trees under the age of exploitability. Trees of service are mature trees ready to be exploited. Trees of no value are mostly old senescent and decayed trees. However, sometimes inaccessible useful trees were counted into trees of no value. So sometimes old trees are overestimated and mature trees underestimated. Woodland were dominated by trees of no value at 81%. Trees of expectation and trees of service represent, respectively, only 17 and 2% of the total tree amount. We note significant difference between tree species. Young trees dominate for elm, spruce, and larch, while trees of no value dominate for oak, pines, beech, and fir. Spatial analysis allows to analyze this distribution at various scales and demonstrates a high spatial heterogeneity. This spatial distribution can also be performed for each tree species, as you can see here for pines. To conclude, the first forest survey allows a good reconstruction of forest cover despite the absence of some trees species and the misidentification of pines. The second survey has a lower accuracy and it is less appropriate for a good forest cover reconstruction. Because of the difficulty of comparing the two surveys datasets, the evaluation of changes in forest cover must be done at local scale only and through an in-depth analysis. The first survey is also a good tool for reconstructing woodland composition from the regional scale to the individual woodland scale. Age composition can be evaluated but with caution and through a detailed analysis. The next step is to refine age composition analysis by integrating tree size information to evaluate the corresponding age of each category. Then, we should integrate paleoecological and other historical data, focusing maybe on some case studies like old-growth forest. Final wish would be to create an historical forest atlas of Provence web GIS. Thank you for your attention.